want to talk through some of the definitions surrounding equations. So first, let me just put an equation up here. So this is 2x plus 3 equals 5. Now, I know that's an equation because it has an equal sign in it, and that's key. If I don't have an equal sign, then it's an expression. We're talking about algebraic expression, so it's probably an algebraic expression if it doesn't have an equal sign. I simplify algebraic expressions, meaning that I combine like terms, get rid of parentheses, that kind of thing. But I solve equations. So we solve these guys. And in fact, solving an equation is finding all the values maybe not 4, but all the values that, when substituted, make the equation true. Now you may be yelling at your computer screen right now and telling me it's x is 1, x is 1, x equals 1. X has to be 1 because 2 times 1 plus 3 is 5. I know. Okay, I know. Just wait for it. But it's actually important. This equation, just by itself, is just a statement. Right? It just says that if you take 2 times whatever x is and add 3, the result will be 5. Now that statement can be either true or false depending on the value of x, right? In solving an equation, we're trying to find the values that make the equation true, but the equation doesn't have to be true. It doesn't have to be a true statement, okay? So just depending on what x is will depend on if this equation is true or not. But as you are thinking, like our goal really is generally to find out, well, what values would make it true. Right? What values, if I put in there, would make that a true statement? We call those values. So those values that make an equation true are called either the solutions or the roots of the equation. So for that equation we have, we could say 1 is a solution of 2x plus 3 equals 5. Or we could say 1 is a root of 2x plus 3 equals 5. And now, how do I know that those are right? How do I know that those are my solutions? Well, besides being able to hear you here in the past from where you're yelling 1 at your computer screen in the future, I also know that if I were to put 1 in here for x, and then do the arithmetic. Let's see, order of operations says I need to do that multiplication first. 2 times 1 is 2. 2 plus 3 is in fact equal to 5. That's true. So when I put in that 1, I get something true. Okay, that's absolutely what it means to be a solution. Sometimes we'll also say 1 satisfies 2x plus 3 equals 5. Because when I put it in, it's true. Okay, it's a solution, so it satisfies. We'll also sometimes talk about the solution set. So the solution set of an equation is, and this is not going to be surprising, the set of all solutions to that equation Okay, so if I have an equation and I want to talk about its solution set, I just make the set that is its solutions. So, for example, 2x plus 3 equals 5 has solution set. Ready? Here I go. I'm going to write it in roster form. The set that has 1 in it. Okay, not very exciting, right? It's the solution set. There's only one guy. So here the solution set is just the set containing 1. Okay, one more small definition, and then I think we'll have all the words we need to know to talk about equations, or at least linear equations. Two equations are equivalent if, and only if in fact, they have the same solution set. Okay, two equations are equivalent if they are the same. They have the same solution set, right? They're the same power or strength or something important about them is the same, because that's how we use that word equivalent in mathematics. So, for example, 2x plus 3 equals 5 and 2x equals 2 are equivalent equations. Okay, they're equivalent equations because they both have the solution set that just contains 1 in them. All right, I think we've got our terminology and definitions, so I'm going to stop this video here.